What up, guys? So today we're looking at section 1.6, simplifying rational expressions. So what is a rational expression? Well, a rational expression is defined as basically just a fraction with a variable like x in the denominator. So a lot of the techniques used in this section are pretty similar to what you've been doing with fractions that just contain numbers. So if we were to relate it to the real numbers, stuff you guys have seen before, if we had a fraction like 24 over 16, for instance, and we wanted to simplify this, what we would do is we'd factor out the greatest common multiple, or the greatest common factor, which is 8 here, right? We have 8 times 3, that's what 24 is multiplicatively, and 16 is 8 times 2. And so, well, we can rewrite this as 8 over 8 times 3 over 2. And anything over itself is just 1. So we get 1 times 3 over 2, which is just 3 over 2. And sure, if you want to, you can just cross these out, but I'm just showing the explicit way. So what does the polynomial version look like? Well, okay, assume we have x squared plus 18x plus 16 over... let's try that again, over x squared plus 11x plus 28. So remember what we did in the first step was we factored it down. So we're going to need to factor, and this should be, 8x. We're going to need to factor the numerator first. I mean, it doesn't really matter which order you do it in, but that's the order we're going to do it in. And so we're looking for PQ that multiplies to 16, but P plus Q that adds to 8. And so, well, 4 times 4 is 16, and 4 plus 4 is 8, so that's what P and Q is going to be. And since this is a 1, right, in front of the x squared term, we know that it's just going to factor down into x plus 4 times x plus 4. Okay, and what about the bottom terms? What P times Q gives us 28, but P plus Q gives us 11. Well, 7 times 4 is 28, and 7 plus 4 is 11. So, and once again, we have a 1 here in front of the x squared, so it's just going to factor into x plus 7, x plus 4. And so what you'll notice here is we kind of have the same situation we had here, where we have a term on the top and the term on the bottom being multiplied. That's exactly the same. And so, we can do the same thing we did before. And so we'll write x plus 4 over x plus 7 times x plus 4 over x plus 4. And notice that anything over itself is just 1, so we have x plus 4 over x plus 7 times 1, which is equal to x plus 4 over x plus 7. And that's our rational expression written in simplest terms. So, cool. So moving on to our next topic, multiplying rational expressions. And so how can we relate this to the real numbers? Well, it's basically just multiplying fractions. So how would we multiply something like this? Well, with fractions, we multiply top to the top, bottom to the bottom. So we get 4 times 2, which is 8, 7 times 3, which is 21. And you're essentially going to do the same thing. Now, if we had anything to reduce, we could have reduced it over here. So this is actually just going to be the simplest form. And so there's nothing left to do here. So let us try a polynomial version or a rational expression version. So assume we have x plus 4 over x squared plus 2x plus 1 times x plus 1 over x plus 5. And so what you're going to want to do first is, just like in this case, if we had, for instance, let's change this to 4 over 7 times 3 over 2. we could just multiply this out, right, and get 12 over 14, and then reduce this to 6 over 7. But rather than waiting to simplify at the end, what we can do here is, right, we can rewrite the 4 as 2 times 2, and since we have a 2 on the numerator and a 2 on the denominator, we can reduce the fraction first, right, and then not have to simplify it later. And when you're multiplying polynomials, because the multiplication here takes necessarily longer because we have to distribute, right, the rainbow method, it's a lot quicker, easier, and simpler to just do our reduction or simplifying at the beginning. So here we only have these 3 terms here are just binomials, but if we look at this trinomial, maybe there's a way we can factor this so something will cancel. And what you'll notice is there is, and we're looking for p plus q to add the 2, but p plus q to, p times q to multiply to 1. And it should be somewhat obvious because the only numbers that multiply to 1 are either positive 1 or negative 1. And since this is plus 2, we want the positive 1 version. So 1 plus 1 is equal to 2, and 1 times 1 is equal to 1. So this denominator of this rational expression will just factor into x plus 1 over x plus 1. And you're probably seeing where this is going already. Look, we have the same term in the numerator of the second rational expression, so we can just cancel these guys. And so what are we going to have left over? Well, just x plus 4 on top, and then x plus 1, x times 5 on the bottom. Okay. All right, so let's move on to the last topic of this lecture, which is dividing rational expressions. And so this should also, the methodology or the logic behind it should be pretty familiar to you as well. So how are we going to do this? Well, the same way we would do it as if they were numbers. So if we had 2/3 divided by 5/2, well, remember that we don't like dividing fractions. We would rather multiply by the reciprocal. So we can write this as 2/3 times 2 over 5 instead. And then because this is multiplication, we just multiply top times top, bottom times bottom, and we get 4/15. And so the polynomial version is going to look pretty much just the same. X plus 4 over x squared minus 1 divided by x plus 2 times x plus 1. X plus 2 divided by x plus 1. And so we can employ this idea here too. Rather than dividing by this fraction, let's multiply by the reciprocal, which just means the fraction flipped. And so now we have x plus 1 on top and x plus 2 on the bottom. But before we multiply, let's see if we can simplify anything. And if you look here, you'll see a pattern that you should recognize. The difference of squares, and we know the difference of squares factors into, it's a squared minus b squared, and this factors into a plus b, a minus b. Essentially conjugate pairs, so x plus 1 times x minus 1. And so what you'll notice now is that we have an x plus 1 in the numerator and x plus 1 in the denominator. And so we can cancel these terms. And what are we going to get? Well, x plus 4 on top. Remember, this just becomes a 1 essentially when you cancel. And on the bottom we have x minus 1, x plus 2. All right, well, cut the video there, and then in the next short video we will do adding and subtracting rational expressions and simplifying complex rational expressions. See you in the next one.